So now that we've talked about what a pH scale is and what a pOH scale is and the difference in the concentrations, now we need to learn how to mathematically convert between the two. Before we can do that, there's a super important, your favorite topic rule, significant figures. Okay? And there's only really one thing I have to say. Only the digits after the decimal in pH or pOH are significant. So for example, if you have a pH of 4.331, this is considered 3 significant figures. So your hydronium ion or your hydrogen ion concentration would be written with 3 sig figs, which in scientific notation is normal. Now, the easiest way to explain this is if I had a pH of something like 14, doesn't matter, decimal, whatever, but if I had a pH of 14, and I was supposed to only write this with 1 sig fig, that would be a pH of 10. And a pH of 14 is very different than a pH of 10. In fact, it is, I'm horrible with my 10 times scales, 10,000 times more acidic. So a pH of 10 is 10,000 times more acidic than a pH of 14. So if we rounded 14 to 10, that would be a disaster. Okay, so the rule is, and you just have to remember this, that you just ignore everything to the left of the decimal in pH or pOH. And then that tells you how many sig figs to write in your concentration. Or vice versa, if you have 3 sig figs in your concentration, you're going to put 3 decimal places in your pH or your pOH. Now, how do we actually convert between the two? Well, like I was mentioning on the previous lesson, it's a logarithmic scale. You do not need to know what that means to be able to solve this. I'm just going to tell you the buttons to push, and you're going to put these formulas onto your formula sheet, or they're already there. Okay? So, to find pH, you're going to take the negative, so it's like -1 times the log. There's a literal button on your calculator that says log of the hydrogen or hydronium ion concentration. For example, if I give you a hydronium ion concentration of 1 times 10 to the negative 13, we already know, right? We already know that when the concentration of hydrogen is times 1 times 10 to the negative 13, that the pH is 13. We just have to make sure our calculator can give us this answer because they're not going to all be this easy. So what you're going to plug in is that the pH is equal to the negative log of 1 times 10 to the negative 13. Now, to plug this in, you literally type a negative sign, then you hit the log button, which is log. Then you only need brackets if you're going to do 1 times 10 to the negative 13. If you do it as 1 exp negative 13, it knows you're talking about one term. So for my calculator, I'm going to hit 1 exp negative 13, and then I don't need brackets. But if you're going to type in 1 times 10 to the negative 13, make sure you use brackets. And I get 13 as an answer. Okay, it works. Now, let's talk about sig figs. This is 1 sig fig in my concentration. This is a pH of 13. That is decided. That 1 sig fig tells me that I would tell you the pH is 13.0. 1 sig fig, 1 decimal place. Okay, pause the video. Try this guy. So the pH is going to be negative log of 0.030. What does that come out as? I feel like that's going to be very acidic. So negative log of 0.03 gives me a pH of 1. And then there are 2 sig figs in my concentration, so I'm going to do 2 decimal places. So 1.52. And yes, that's very acidic, right? So my scale on the previous page went 0 to 14. Not that it can't go below that, but 1.52 would be pretty darn acidic. Okay, what about pOH? Same deal. So to find pOH, you do negative log of the hydroxide ion concentration. So of 1.00 times 10 to the negative 3. Now we know this is going to come out as 3, right, from the previous page, but let's type it in. So negative log 1 exp negative 3, or use brackets, and I end up with 3. Now, 3 sig figs in my concentration means that I would answer to 3 decimal places in my pOH. Awesome. Pretty basic. Not basic in skill. Basic in its acidity scale. Okay, this next one. So this one is going to be very basic. So I'm going to find pOH by doing negative log of 0.0020. Okay, negative log 0.002 is going to give me a pOH of 2 point. Now, 2 sig figs in my concentration, 2 decimal places. Now, since it's 6, 9, 8, I have to round the 9 up to a 10. So this is going to give me a pOH of 2.70. And it's really important that you maintain precision and sig figs. Okay, so what if we have to go the other way? Well, the other way, what we're going to do is that this pH becomes the exponent on the 10. So it's going to be 10 to the negative 13, and that's the formula. So to find the hydronium ion concentration, you do 10 to the negative pH, and to do the hydroxide ion concentration, you do 10 to the negative pOH. Don't forget, only the decimal places in the pH or pOH determine the sig figs in your concentration. So we'll just do 2 simple examples here. So for this one, if I wanted to find the hydrogen, and again, I'm kind of interchangeably using hydrogen ion and hydronium ion. They're a little bit like hydronium is proper, hydrogen is shorthand. Okay, hydrogen ion concentration would be 10 to the negative 6.53. And then we want to write that. So this isn't proper scientific notation because you don't want decimals in your exponent. So you're actually going to type into your calculator 10 to the. So you can use 10 x to the y or a little cap button. Or if you notice above your log button, if you hit second function, there's a 10 to the. So if you want to skip some steps, you can go second function log. It'll go 10 to the. And then you can go negative 6.53. And this is going to give me now 2 decimal places in my pH is going to give me 2 sig figs in my concentration. And I've got 2.95 times 10 to the negative 1, 2, 3, 4, 5, 6, 7. So if I was going to round that to 2 sig figs, the 5 is going to round the 9 up to a 10, and I would get 3.0 times 10 to the negative 7, and I need units of molarity. Okay, try hydroxide ion concentration. Now, this should be a very small number because that's quite acidic. Okay, 10 to the, let's forget the 10 to the button. Okay, and now 3 decimal places, so 3 sig figs is going to give me 4.52 times 10 to the negative 13 moles per liter, or molarity. Awesome. Okay, so before we go on to the next lesson where we're going to put these all together, I want you to practice this. So go and practice converting from concentration to pH or pOH, and then pOH or pH back to concentration, just so that process is dialed.